So on the back of your notes, you have the implicit differentiation of, or you're asked to do implicit differentiation for x cosine y equals 1, and then evaluate it at the ordered pair 2, 2, and then pi over 3. So we'll do the derivative with respect to x of both sides of that equal sign. And you do have a product again, so we'll need to do the product rule. So we'll start with x, that's first, times the derivative of the second, which is the derivative of cosine. So we'll have negative sine of y. Now we have to do the derivative of the angle. And because the angle is a y, it'll be a 1, and then I'll go ahead and put the 1, and then dy dx. All right, so that's first times derivative of the second, plus now second, which is cosine of y, times the derivative of the first, which is a 1. So we're taking cosine of y times 1, equals, and then the derivative of 1 is 0. Now, because your instructions say to find dy dx, you must get dy dx by itself. But as I've talked to you in other applications, if your instructions just said to evaluate, then technically you could substitute in numbers right now, and the only variable that you would not have a number for would be the dy dx. And so you could solve, and that actually is quite a bit easier. But this one does ask us to find dy dx, so we'll have to subtract cosine of y to the other side. So we have negative x times the sine of y times dy dx. And that equals negative cosine of y. And then we'll divide both sides by the negative x sine of y to get our dy dx equals, and then we have negative divided by negative, so that's going to be a positive cosine of y over x times the sine of y. And then we are to evaluate the derivative at the ordered pair 2 and pi over 3. So at 2 pi over 3, we'll substitute in. So dy dx would equal the cosine of pi over 3. That's our y value, over, and then our x value is a 2, and then we're doing the sine of pi over 3. Well, the cosine of pi over 3, if you think about that ordered pair, at pi over 3, your x is a 1/2, and your y is a square root of 3 over 2. So, at the angle pi over 3, your ordered pair is again 1/2 and square root 3 over 2. All right, so dy dx would equal 1/2. And then in your denominator, you'd have 2 times the square root of 3 over 2. So we can cancel those 2's in the denominator. So now you have 1/2, and it's divided by the square root of 3, which I'm just going to keep using an equal sign here, would be 1/2 times 1 over the square root of 3, which is going to be 1 over 2 square root 3. And then if you rationalize it, multiplying by the square root of 3 over the square root of 3, you would get dy dx equals the square root of 3 over 6. So your dy dx in simplified form at the ordered pair 2 and pi over 3 would give you square root of 3 over 6. And that would be your slope of your tangent line at that point on the graph.